All right, like I said, there's only 2 questions we have today. Just 2. And here's your first one in 30 minutes, exactly. Well, actually, now I have to do it in 15, roughly, 20. Okay, first things first. I need you to notice something. This is a quotient within a parenthesis raised to a third power. Anytime you're raised to something higher than 1, you're going to have to do a chain rule. You all with me on that? Okay, so then what would be my u?
3x minus 1 over x.
It'd be this whole thing. So on the side of your paper, you're going to write u, 3x minus 1 over x squared plus 3. Okay? Well, y'all, that's a quotient. So how do you take the derivative of a... Got to do quotient rule derivative. All right, so here we go. Denominator times, what's the derivative of the numerator? 3, sorry, thank you. Minus the numerator times the derivative of the denominator, which is 2x, all over denominator squared. Now we need to clean that up. I know, Jack, you can't see it.
Don't worry.
All right, I won't worry about it. All right, let's clean this up. This becomes 3x squared plus 9, right? I just distributed. This becomes distribute the negative and the positive 2x. So that you're actually distributing a negative 2x. So you would get what? Negative 6x squared plus 2x. All over denominator squared. And then even more cleaning up. 3x squared into negative 6x squared. What does that make? Negative 3. It's just algebra. It's just algebra. All right, so this is actually the chain part. That is the derivative. You should end up with negative 3x squared. And notice I like to go in order. Just try to go in order. Keep everything as clean as possible. Plus 2x plus 9 over x squared plus 3 squared. Yes? Do you know that we haven't even actually begun the part of the actual problem yet?
Yeah.
You know, all we've done is just taken a derivative of the inside, but we haven't actually done the chain. Exactly. We haven't even done the chain part. Okay, so here's what now you do. So you are going to, from what we learned last time, rewrite this as what to the third?
U to the third.
U to the third. And now you take the derivative of u to the third, which would be what? And attach what next to it? U prime. Now, you are going to put next inside of the u, you're going to replace it with what the actual u is. And inside the u prime, you're going to replace that. But remember, these are fractions here. So I'm actually going to kind of rewrite it like this. Let me move it up. I'm going to have 3 over 1. Then I'm going to rewrite this u as 3x minus 1 over x squared plus 3 to what power? Squared. Times u prime, which we just found right over here. Negative 3x squared plus 2x plus 9 over x squared plus... This is just algebra from here. All right, now, question. Can that 3 be distributed into here?
No.
Why no? Because there's a power. An order of operation says, please excuse exponents before multiplying. Can that 3 go into this one? Yes, it can, because this is to a power of 1 right here. So I would actually put the 3 distributed into this one right here. So I'm going to actually write it as negative 9x squared plus 6x plus 27. Do you all know where I got that from? Okay. Now, what is this actually, this top part of this quotient? What power is it going to? Square. And so according to fraction rules, if you don't remember, again, you need to, if you have like 4 over x squared, that's the same as saying 4 squared over x squared, right? Okay, so this is actually the quantity 3x minus 1 squared, right?
course.
3x minus 1 squared.
We're just doing numerator, obviously.
You don't have to FOIL. I don't actually want you to FOIL. I only want you to write this much out.
We're just doing numerator, right?
Yeah, numerator, this squared. But on this bottom, you have an x squared plus 3, which is being squared. And you have an x squared plus 3, which is already squared.
To the fourth.
Oh, so just write the bottom as x squared plus 3 to the 4th. And that's where I want you to stop. You do not have to FOIL anymore.
That's it?
Is that it?
That's all you want?
That's what I want. Oh, people, I haven't done 2 on you yet. Come on.
I was expecting like over
All right. You think this is easy? Just wait.
That's all you got.
Here it comes. Wait for the enjoyment.
I am ready. Yeah.
And now comes the fun.
Black shell situation.
Are you ready? Oh, I'm ready for this already. All right, you have x squared times the square root of 1 minus x squared. First things first, let me rewrite this as x squared time with parentheses, 1 minus x squared to the what power? 1/2. All right, so what would our u be?
1 minus x squared.
Put it on the side of your paper. 1 minus x squared, take the derivative while you're there, negative 2x. Would you all agree?
Yeah.
Okay. Oh, here it comes. Here it comes, kids. You ready? All right, I am going to now rewrite this. I just rewrote it, but I'm actually going to rewrite it with u's inside first, before I even begin. So this would be x squared, what? U to the 1/2. Have I taken a derivative yet of this?
No.
Okay. How do you take the derivative of this, kids?
You gotta get the email first.
No.
You have to multiply the 1/2.
You have to do product rules.
Excellent, Jack.
Wasn't there one? There's one.
This
38 on the.
That's why I didn't assign it, yeah.
Yeah, I did it.
I know, I'm so proud of you. This
That was me, guys.
I already did. I did it too, but I have to.
y'all, this is a product. You have to do a product rule. Okay, wait, it gets fun. We haven't even begun. Let's go. This is so good. I cannot wait. I am so excited. Okay, product rule goes like this. Product rule says first, which would be x squared, times the derivative of the second. What is the derivative of u to the 1/2? Be careful.
Negative
1/2 u to the negative 1/2. Wait, you didn't say it though. Times what?
Times you prime.
Times u prime. You need to write this down. Whenever you take a derivative of u, you need the chain, which is u prime. You can't just take a derivative of u like you would take a derivative of x. You have to attach good old chain. Only when you take a derivative of it, not when you include it, just when you take the derivative. So first times derivative of the second times its chain, plus, what would come next?
The derivative of the x squared.
Well, okay, you want to do it that way? I always do first times derivative of the second plus second. I always do second, but thanks. Do I have to include the chain here?
No.
Why?
You just did.
I didn't take derivative. Times the derivative of the first. What's the derivative of that? Okay,
Wait, why did you do that last time?
because that's the product rule. First times derivative of the second plus second times derivative of the first. Okay. Okay, now this is getting better. Y'all, this is getting better. Now it's just algebra from here on out. This is so good. It's so good. Now we're going to plug in our u's and u prime. And we're going to make this look even smashingly awesome.
I love how I can look like.
Let's go. Let's go.
Thank you. U we have established as 1 minus x squared to the negative 1/2. U prime was negative 2x. I'm going to include it in a parenthesis because I don't want to be mistaken as it being something else. Plus, 1 minus x squared to the 1/2 times 2x. And we just are cleaning up from here, kids. But wait, there's still more. I'm so excited. Okay, question. We've got to clean this up to the best we can and using our algebra skills, okay? Can I combine this 1/2 with this x squared? You sure can. You can combine monomials with monomials. Could I combine it with this negative 2x?
Yeah.
You sure can. It's not going to any power. It's a monomial. So really, let's just put all these together in the front. What's an x squared times a 1/2 times a negative 2x?
X squared.
Negative 2x squared.
X cubed.
No,
Negative x.
Negative x cubed. Okay? So negative x cubed.
Wait.
Half of negative 2 is negative 1, and then x squared and the x make x cubed.
All right.
Okay? I'm going to leave this just like it is, 1 minus x squared to the negative 1/2. Plus, I'm going to take this 2x. There's a method to my madness. There's reasons. I'm going to put it to the front, and then leave this as 1 minus x squared to the 1/2. And this, my friends, goes way back to September, when you had to simplify, and I gave this actually to you as a problem, by factoring.
Can you take out the exponent?
I get the lowest exponent.
Yes!
I meant that. I swear. I meant that.
Factor out the lowest powers. So let's start with the monomial parts first. What could I factor out?
Negative 1/2.
No, from these two right here.
X.
An x, just an x, right? You could factor out a negative, but I'm just going to factor out an x, okay? And then don't they have this same quantity, right? And what power am I going to factor that out? Negative 1/2. And then remember me doing this with a bracket? Remember that? Going all the way back to September?
Oh, no.
So if I took out x times the quantity at 1 minus x squared to the negative 1/2 from here, what would I have left? Let's see. What's a
X squared.
negative x squared? That's all I have.
A long time.
Remember that? Yeah. And remember I said, guys, this is an actual problem you'll do future-wise.
But this is like.
Plus, would I not have a 2?
You got one of that.
And then I'd have 1/2 minus a negative 1/2, which is one whole quantity of this, correct? So 1 minus x squared. Remember when we divide exponents, we subtract the exponents?
So they.
Yeah. All right. And then again, it's simple algebra, y'all. Cleaning up.
Simple.
Negative x squared plus 2 minus 2x squared. And what does that really become? That becomes negative 3x squared plus 2. You have this x, you have this 1 minus x squared to the negative 1/2. And now where does everything properly belong?
So nice and clean now.
That. So you can distribute this x through if you want to. I think I did. So I think I called it negative 3x cubed plus 2x over 1 minus x squared to the positive 1/2. My good old friends.
You're done.
Boom!
Forever.
Boom!
Whoa. That was like a ball.
That was everything you have learned thus far. Y'all! Drop a mic. That's it.
That's it.
That's why it's like.
That's it.
Now, you've got 5 problems for homework tonight.